Hello everyone. For this problem session, I am going to be working through problem number 4 that says to show that the square root of 4 plus 2 square root of 3 minus the square root of 3 and the square root of 6 plus 4 square root of 2 minus the square root of 2 are rational numbers. So for this problem session, I'm actually going to be going through this problem in two different ways using two different methods. The first way is going to be how we did it in class in the previous lecture, and the second way is going to be by actually manipulating terms in each of these expressions to go ahead and solve and show that both of them are rational numbers. So let's get started with the first problem using the first method. So we are going to show that 4 plus 2 square root of 3 minus the square root of 3 is rational. So to do this, we're first going to let alpha equal the square root of 4 plus 2 square root of 3 minus the square root of 3. And then we're going to use basic algebra steps throughout the entire problem to solve this down. So what we're going to first do is we're going to add square root of 3 to both sides. And then from here we're going to square both sides so we can get rid of this square root. So we have alpha plus square root of 3 all squared equals 4 plus 2 square root of 3. From here we're going to go ahead and expand this out, and we're going to get alpha squared plus 2 square root of 3 alpha plus 3 equals 4 plus 2 square root of 3. Then from here is we're going to move all the square root terms to the right hand side and all the regular constants to the left hand side. So when we do that, we're left with alpha squared minus 1 equals negative 2 root 3 alpha plus 2 root 3. And then we could go ahead and factor the left side to alpha plus 1 times alpha minus 1. And then on the right hand side of the equation, we can factor out a negative 2 root 3. And then we're going to have that times by alpha minus 1. Now we can move all the terms over to the left hand side of the problem. So we have alpha plus 1 times alpha minus 1 plus 2 square root of 3 times alpha minus 1 equals 0. From here we can factor out an alpha minus 1, and then we're left with alpha plus 1 plus 2 square root of 3 times alpha minus 1 equals 0. So from here this means that either alpha minus 1 equals 0 or alpha plus 1 plus 2 square root of 3 equals 0. So what we're left with is either alpha equals 1 or alpha equals negative 1 minus 2 square root of 3. So the reason we can throw out this solution is because we started where alpha was greater than 0, and this solution is negative, so this solution is impossible. So we're left with alpha equals 1, which shows that this is a rational expression. Moving along, we can use the same logic to show that the square root of 6 plus 4 square root of 2 minus the square root of 2 is also rational. So once again, we're going to let alpha equal the square root of 6 plus 4 square root of 2 minus the square root of 2. And we're going to go through this with basic algebra steps again. So we're going to move square root of 2 over to the left-hand side by adding it. And then we're going to square both sides. So we have the quantity of alpha plus the square root of 2 all squared equals 6 plus 4 square root of 2. We can go ahead and expand this out, and we get alpha squared plus 2 root 2 alpha plus 2 equals 6 plus 4 square root of 2. Then we're going to go ahead and move all the constants to the left-hand side and then all the square roots to the right-hand side. So we get alpha squared minus 4 equals negative 2 root 2 alpha plus 4 root 2. On the left-hand side, we can go ahead and factor this, and we get alpha plus 2 times alpha minus 2. And then on the right-hand side, we can factor out a negative 2 square root of 2. So we get negative 2 square root of 2 times alpha minus 2. And then we can go ahead and move everything to the left-hand side of the equation. So we have alpha plus 2 times alpha minus 2 plus 2 square root of 2 times alpha minus 2. And then we see that alpha minus 2 is in both terms, so we're going to go ahead and factor that out. So we get alpha minus 2 times alpha plus 2 square root of 2. So this means that either alpha minus 2 equals 0 or alpha plus 2 square root of 2 equals 0. So from here we see that either alpha equals 2 or alpha equals negative 2 minus 2 square root of 2. So using the same logic as before, this solution is impossible since we started out with an alpha that was greater than 0, and this solution is negative, so that's not right. So we're left with alpha equals 2, which is our rational solution that shows that this is also rational. Just for fun, I went ahead and solved this using a different method by manipulating terms in each of the expressions to also show you how these are rational numbers. So what we're going to do is we're going to first start by rewriting the square root of 4 plus 2 square root of 3 minus the square root of 3 by rewriting the 4. So we're going to change that to 3 plus 1 since 3 plus 1 is also 4. And then from here we're actually going to go ahead and rewrite the 3 and the 1 again to manipulate it without changing the value of these. So we're going to rewrite 3 as the square root of 3 squared, since the square root of 3 times the square root of 3 is just 3. And then we're going to rewrite 1 as 1 squared, since 1 times 1 is 1. And then from here, we're actually going to rewrite the 2 square root of 3 term, which we're going to write as 2 times 1 times the square root of 3. So if we let a equal the square root of 3 and b equal 1, then we have the square root of 3 squared plus 1 squared plus 2 times 1 times the square root of 3. And this is very similar to having the form a squared plus b squared plus 2ab, which we know we can factor. So this means that the square root of 3 squared plus 1 squared plus 2 times 1 times the square root of 3 equals the square root of 3 plus 1 times the square root of 3 plus 1, which we can simplify into the quantity of the square root of 3 plus 1 squared. And we can actually take this and substitute it into this part of our expression. So we have the square root of 4 plus 2 square root of 3 minus the square root of 3 equals the square root of the quantity square root of 3 plus 1 squared minus the square root of 3. Then we're actually going to go ahead and rewrite this again as the quantity of the square root of 3 plus 1 squared, all raised to the 1/2 power, minus the square root of 3. And this just simplifies into the square root of 3 plus 1, and then we have our minus square root of 3, and we get that this equals 1. And since 1 is a rational number, the square root of 4 plus 2 square root of 3 minus the square root of 3 is also a rational number. We can use the same logic and reasoning to show that the square root of 6 plus 4 square root of 2 minus the square root of 2 is also rational. So with this, we're going to manipulate the 6 and rewrite it as the square root of 4 plus 2 plus 4 root of 2 minus the square root of 2. Then once again, we could go ahead and rewrite the 4 and the 2. So we're going to change 4 to 2 squared, since 2 times 2 is 4. And we're going to change 2 to the square root of 2 squared, since the square root of 2 times the square root of 2 is just 2. And then when we rewrite 4 square root of 2, we're going to write it as 2 times the square root of 2. So once again, if we let a equal 2 and b equal the square root of 2, then we have 2 squared plus the square root of 2 squared plus 2 times the square root of 2 is also similar to our factorable form a squared plus b squared plus 2ab. So this means that 2 squared plus the square root of 2 squared plus 2 times the square root of 2 equals 2 plus the square root of 2 times 2 plus the square root of 2, which equals the quantity of 2 plus the square root of 2 squared. From here, we could go ahead and take this and substitute it into this part of our expression. So the square root of 6 plus 4 root 2 minus the square root of 2 equals the square root of the quantity 2 plus the square root of 2 squared minus the square root of 2. We could go ahead and rewrite this as the quantity of 2 plus the square root of 2 squared, all raised to the 1/2 power, minus the square root of 2. This simplifies into 2 plus the square root of 2 minus square root of 2, and we're just left with 2. And since 2 is a rational number, the square root of 6 plus 4 square root of 2 minus the square root of 2 is also a rational number. So in either case, we were able to show that both these expressions were rational numbers.